Now I'm going to start with figuring out the angle of the rungs, the side rungs. So I'm going to go back to my trapezoid. Remember when I had a fully assembled frame, the corners of these were centered on, each corner was the center of one leg. So this is a trapezoid created by connecting the centers of each leg. This run represents the center to center dimension of the front panel. So from the center of this leg to the center of that leg. This run is the center to center dimension of the rear leg, center to center. And then this would be, when we have the construction fully assembled, center to center of the side rungs, looking at it from the side. So this is an accurate representation of the trapezoid created by the legs and rung lengths that we have. So if we take this trapezoid and rotate it, get this leg parallel to the framing square. So what we're looking at now is we're trying to figure out if this is the rungs, and our front leg, one of our legs is going to be here. Again, this is still the path of the drill bit. We're trying to get the drill bit. This drill bit, trying to get we're trying to rotate the part in a way that the drill, that the path of the drill bit matches the angle that we're going for. So you can see that we have a gap up here, and should be that pretty close. They're not always exact, but close enough is good. In this, there's a lot of flexibility in the assembly. So that's the gap, which is 3 3/4 of an inch. So this introduces the principle of how we talk about angles in these chairs. I don't know any angles in the chair by degree. The only angles we know, the way we talk about angles is using rise and run. So for this angle, the run is 21 1/8, and the rise is 3 3/4. That's the angle. That's the angle that we're after, and that's a way to describe it. And it's a great way for describing angles. It's very, very accurate. We're making our we're measuring our angle way away from the intersection down here. If we tried to measure this angle down here with a protractor, it'd be really hard. And any little variation here would expand into a large variation where it matters up here. Any small variation here doesn't really matter. It's just a very small variation. So it's very accurate. So this is the jig for drilling the side rungs into the front panel. So I'm going to put the side rungs into this leg, and then I'm going to set this up here. You should be roughly vertical. So if you wanted to drill all 6 side rung mortises, you would assemble the front panel, glue it up, put it together. To drill all 6 front mortises into this assembly, this is the jig, just the riser block that's 3 3/4.
Can you explain why we're talking about a trapezoid that goes from center to center, but it's okay to put the jig under the side of the leg?
Yes, we're off by the half the diameter leg on both of these.
So the difference is equal, and that makes it okay.
Equalize, yeah. Okay. So you can work from a trapezoid that's the center of center is the most accurate. You could do outside to outside, but you would not get the same you would not get the same angle. It would vary slightly. So center of center is actually the most accurate, and then you're just going down half that diameter on both both sides. So if you were paying attention, when we're drilling into the front panel, we raise the opposite leg that we're drilling. On the rear panel, it's reversed. On the rear panel, we're gonna raise the leg that we're drilling, and that matches this riser block, which is 2 3/4 of an inch. So you can do all of this measuring and coming up with angles by drawing these full scale, by drawing them on paper, by drawing them on a computer, whatever you need to come up with this height. That's the critical thing. You draw an accurate trapezoid, however you draw it, you should get roughly the same results every time. So 2 3/4 is the rise of the rear panel. And the run, so the angle for the rear panel is, in rise and run, would be 2 3/4 rise, which is this, which is that, over a run of 15 5/8. That's the angle. So now to apply it to the assembly, when we're ready to go, we take this riser block, which is 2 3/4, and set it under the rear leg, and now these should be parallel. That looks pretty good there. So with this riser block, we can now drill all 6 mortises into. So we would assemble the rear panel. Remember, there's going to be the top of the legs will be out here. Assemble the rear panel and set it on this riser block and drill these. Flip it around, drill these. So all 6 side running mortises with this simple riser block. So to do every single, there are 20 mortises, there are 10 rungs, 20 mortises. The drilling with the drill press, the drilling jigs are riser block for the rear panel, riser block for the front panel, different heights, and our platform jig with a couple of slots in it. That's the whole kit. That's it. And it's incredibly accurate and very fast. I can drill all these mortises if I have an assembled front panel. Well, I can drill all these mortises less assembly time in less than half an hour. They'd be dead on accurate every time. It's a really great way to do this. Drill press required. So I'm going to ask you a question. You're going to be the audience, Mark.
Okay.
So this angle here does not change when we just flip this over. It's the same angle, right? Mm-hmm. As the front panel, but on the front panel, we need to use a riser block that's an inch taller than this one. Why the difference? Why the different heights?
The run is longer.
The run is longer. That's the answer.
Okay. Yeah.
The run is different.
Yeah.
Shorter run here, longer run here, same angle, and I'm gonna show you that. We're measuring the angle, but then from that we're making a riser block. We're getting the height of the riser block for the drilling into the front panel, and that's 3 3/4, and that's the full run of 21 1/8. I put this mark down here. This mark is the run of the rear panel, which is 15 5/8. And if I take this riser block and set it there, there's my 15 5/8. So it's a continuum. It's the same angle, shorter run, shorter rise, longer run, longer rise. It's a beautiful system. I mean, it's just amazing how simple it is. And with the drill press, no muss, no fuss, dead on accurate, fast. And get back to what you really like doing, the shaping parts.
Shaping parts. Draw knife and spoke shape work.
Yeah. So I put the assembly back together, and we can then demonstrate it once again. Front panel, if you're drilling the front panel, it would get these, it would essentially get the legs to touch at vertical, the outside of the legs, which they do. Flip it over. Rear panel, on the rear panel you put the riser block on the leg that you're drilling, and we should have a similar result. Both legs touch the square right there. That's it. Okay.
Great.
So that's it on the simplest form of post and rung chair. In the next video, I'm gonna show you a couple of chairs that are constructed this way, and talk about how, if you wanted to reproduce that chair, how you would measure the drilling angles.
Oh, great.
Yeah. Okay.